Hi everyone, and welcome to your next video titled Simplifying Rational Expressions. So let's talk about what a rational expression is first. Well, the word rational has a root word, ratio. Okay, ratio, and when we think of the word ratio, we think of fractions. So all of our examples today, we will be simplifying fractions, expressions that are fractions. Now, each of these has a stipulation on the x value, and we'll talk about why that is. You see here, x cannot be 4, down here, x cannot be -4 or -3, and etc. So we'll talk about that, but we're going to be simplifying. And the way you simplify rational expressions is you factor first. So I'm going to write that here, factor first, and then you simplify. Okay? So factor first and then simplify. Now the thing about the factoring though is you're going to have to factor the top and the bottom, and once you factor the top and the bottom, you'll see if you have any similarities that can be crossed out. Okay, so let's take a look at the first one. Example 1, simplify 3x minus 12 divided by 5x minus 20. X cannot equal 4. Well, first let's talk about why x can't equal 4. Well, let's plug 4 in to this expression and see what's going on at 4. So if I evaluate this for x equals 4, I would get 3 times 4 minus 12 over 5 times 4 minus 20. And that would result in 12 minus 12, which is 0, and 20 minus 20, which is 0. And so this right here is a big no-no. We don't like 0 in the denominator of a fraction. So because this value creates that drama, we're going to take that out of the domain. X cannot be 4. So you don't really have to do anything with this. It's just if you see it there, this is why. It's like a little limitation on the problem. So don't let that confuse you. Now we go back to the problem. So let's look at the top. Let's try to factor 3x minus 12. Now you know the first thing we always look for is a GCF, and the GCF of 3x and 12 is simply 3. So we're going to pull that out. Now what are we left with? Well, we divide each of these by 3, and 3x divided by 3 is x, and 12 divided by 3 is 4. And that's about as much as I can do with that. That is completely simplified. On the bottom, the GCF for 5x minus 20 is a 5, and I'll be left with x minus 4. So now I have 3 times x minus 4 divided by 5 times x minus 4, and so I may cancel out these x minus 4s, cancel, cancel, and I'm just left with 3 over 5. Final answer. This is the simplified version of this rational expression. Okay, let's go to the next one. Example 2, simplify, and then we've got this rational expression. This time, x is excluding two different values, -4 and -3. So let's just see what happens here. If I were to plug a -4 into this, for example, I would have -4 squared plus 2 times -4 minus 8 all over -4 squared plus 7 times -4 plus 12. So if I do this math here, this is going to give me 16 minus 8 minus 8, which is 0, and 16 minus 28, which is -12 plus 12, and that's 0. So there it is. This is the reason x cannot be -4. Now what about -3? Well, I would do it all over again. -3 squared plus 2 times -3 minus 8 over -3 squared plus 7 times -3 plus 12. So this is going to be 9 minus 6, right? 9 minus 6, which is 3, minus 8 is negative 5. 9 minus 21, negative 12, plus 12, 0. So again, 0 on the bottom, no good. And so that's why these two values of x are excluded. But we don't really have to do anything with that. We just have to know why. Okay, so now we will factor the top and the bottom and see if we can simplify. So let's start with x squared plus 2x minus 8. Well, I don't have a GCF here because between a 1, a 2, and an 8, the numerical piece of the GCF would just be 1. And since the 8 doesn't carry any kind of x with it, we don't even have a variable portion of our GCF. So I'm going to go forth and break this down like we have done in the past into my two quantities. I know I start with x and x, and now I need two numbers whose product is negative 8, but whose sum is 2. So two numbers whose product is negative 8 would be a 4 and a 2, but the sum has to be a positive 2, so I'm going to keep a positive 4 with a negative 2. Now you can check that. Here's your x squared, your negative 2x, your positive 4x, that makes your 2x, and your negative 8. Okay, I'm going to do the exact same process for my bottom here. X squared plus 7x plus 12. And I've got x and x, two numbers that have a product of positive 12 and a sum of 7 would be positive 4 and positive 3. Now looking top to bottom, do you see anything that's exactly the same? See how they both have a quantity x plus 4? Since these are exactly the same, top to bottom, you may cancel them out. Your final answer, x minus 2 divided by x plus 3. Now, I want to talk to you about something on this problem that's really, really important. And even my calculus students sometimes mess this up. When you have x minus 2 divided by x plus 3, it is very tempting to cancel these x's out and just say, hey, my answer is negative 2/3. That would be totally illegal mathematically. And I want to show you why. If you plug in, let's just do a little, actually I can take this to the back. So what, x minus 2. So x minus 2 divided by x plus 3. Let's pick a value for x. Let's let x equal 10. Okay, so if x is 10, then the top would give me 10 minus 2 over 10 plus 3. And that answer is 8 over 13. So when x is 10, this expression gives me 8/13. Well, if you go canceling these x's out, it looks like the answer is negative 2/3. These don't match. So you cannot cancel these x's out. So my rule of thumb is this. If an x is hooked up with either subtraction or addition to another term, you may not just cross out a piece of that polynomial. Now, the only case where you can strike out x's like that would be if they're working across multiplication. So like if you had this, x times 4 over x times, let's say, 7. Now, you may cancel out those x's and say the answer is 4/7, and here's why. Let's let x be 10 again. Well, if you had 10 times 4 over 10 times 7, that would be 40 over 70, which reduces right back to 4/7. Let's choose something else. Say x was 2. Well, you'd have 2 times 4 over 2 times 7, which is 8/14, which reduces right back, if you divide each of these by 2, to 4/7. So no matter what you put for x here, the final answer will always be 4/7, and you can see these x's are working across multiplication. So top to bottom, if you're going to cross something out, that something you're crossing better be operating on multiplication, not subtraction or addition. Okay, back to the front. So let's go to example 3. We're going to simplify x squared minus 64 divided by x squared minus 11x plus 24. Look at my domain here. X cannot be 3 or 8. Now, I won't go off for time's sake, but if you would plug 3 and 8 into this, the denominators would be 0. That's why they're excluded. So let's just get into factoring. So my top here, x squared minus 64, is the difference of two perfect squares. So that factorization is going to be x plus 8, x minus 8. Now I'm doing that quickly because we've already studied this. The bottom, again, no GCF in sight. So I'm going to go right to two parentheses. I need two numbers whose product is positive 24 and whose sum is negative 11. And that will be negative 8 and negative 3. Now you scan it, anything similar top to bottom, you see an x minus 8 with an x minus 8. It all goes out, and I'm left with x plus 8 over x minus 3. Final answer. We may not cancel these out because of what we just discussed on the back side. All right, so this is how you simplify rational expressions. Factor, factor, cross. Okay, thanks for watching.